These are images of a terrestrial and an aquatic ecosystem. You can see that in both these ecosystems, the energy flow begins with the sun. In fact, the sun is the only source of energy for all ecosystems on Earth except for the deep-sea hydrothermal ecosystem, whose primary source of energy is the heat produced inside the Earth's crust. Of the sun's incident radiation, less than 50% is photosynthetically active radiation, or PAR, which is the spectral range of solar radiation that can be used by green plants for photosynthesis. However, in reality, plants utilize only about 2 to 10% of PAR, and incredibly, this small amount of energy sustains the whole world. In all ecosystems, the solar energy tapped by plants or producers is converted into chemical energy and is passed on to all other organisms. All organisms which are directly or indirectly dependent on producers for their food are known as consumers. Hence, there is an unidirectional flow of energy from the sun to producers and then to consumers. This flow of energy in the ecosystem can be depicted by a food chain, which also shows the interdependence of organisms. Here we can see that producers are food for herbivores, which in turn are food for primary carnivores. Likewise, primary carnivores are food for secondary carnivores. Thus, the energy of an organism in general does not remain inside it, but either flows to consumers or to decomposers when it dies. Now, in nature, there are two types of food chains: grazing food chain, or GFC, and detritus food chain, or DFC. Most ecosystems in nature follow the GFC. In a GFC, the energy flows from producers to grazing herbivores and finally to carnivores. Here we can see that the grass, deer, jackal and lion form a simple GFC. Another example of a GFC is an aquatic food chain comprising phytoplankton, zooplankton, small fish and large fish. The second type of food chain, that is the DFC, begins with detritus, or dead organic matter, which forms the primary source of energy. This detritus is broken down into simple inorganic materials by digestive enzymes secreted by decomposers or saprophytes, and is then absorbed by them to meet their nutrient requirements. Detritivores or decomposers may be consumed by detritivore consumers, which, in turn, may be preyed on by small or large carnivores. The DFC is usually shorter than a GFC. An interesting fact about GFC and DFC is that they may be connected at certain levels. This happens when an organism belonging to the GFC dies and enters the DFC, or when omnivores such as crows prey on organisms from the DFC. Such interconnection of food chains leads to the formation of a food web. It is also seen that the GFC forms the main channel for energy flow in aquatic ecosystems, while in terrestrial ecosystems, most of the energy flows through the DFC. Now, all organisms in a food chain occupy a specific place in the ecosystem depending on their source of food and nutrition, which is known as their trophic level. Producers belong to the first trophic level, followed by herbivores and finally carnivores. Also, the amount of energy decreases in successive trophic levels, and organisms at each trophic level fulfill their energy requirements from organisms at the lower trophic level. In addition, each trophic level has a certain mass of living material at a particular time, known as standing crop. It is measured as the biomass or the mass of living organisms or the number in a unit area, and is expressed either as fresh or dry weight. However, the number of trophic levels in a GFC is restricted and is anywhere between 3 and 5. This is because the transfer of energy follows a 10% law. That is, on average, only 10% of energy is transferred from one trophic level to another, while the rest is used up for metabolic activities of individuals or is lost as heat. Moreover, all ecosystems abide by the first and second laws of thermodynamics. This is because energy is being converted from one form to another as it is transferred from the sun to various organisms. In addition, the biosphere is continuously losing usable energy in the form of heat, thereby requiring the continuous supply of energy to organisms for the synthesis of molecules to resist the natural tendency of increasing disorderliness. Hence, we have seen that there is a continuous supply and flow of energy in all ecosystems, and this is vital for the sustenance of our biosphere.